Hello and welcome to another tutorial. So this time around we are going to be making some simple spaceship controls. So we're going to be setting this up so we're able to be applying thrust in different directions. We'll be linking up some visual effects and audio associated with that, and we'll be getting that up and running. So let's dive on in. And in terms of what we've got as an initial starting point, so this project I've set it up using the universal pipeline because I wanted access to the visual effects graph. I have put together a basic sort of spaceship setup. Now, a couple of key things with how I've set this up. So one of the big things that I've done is I've got the different engines, and for my own sake, for being able to work out what things correspond to what other things, I have gone and set these up so that they are named based upon the axis they would apply force in. And each of them already has a point where we'll be able to attach visual effects so that we can have those being emitted. I've taken care to ensure that if we look at each of these emitters, and I've set so we're on the local mode for the coordinates, you'll see for each one of these, the z-axis points in the direction that the particles will get emitted. So that's been an intentional thing to ensure that it's going to be emitting them in the correct direction. And although these rockets are placed in this case directly at the sort of 0 point, the actual placement, the location of these isn't going to matter. So that's going to be one of the key things, is that the forces that get applied, which will be going through a rigid body, which I've set this so its mass is a kilo, sorry, not a kilo, 1,000 kilos. The forces are going to be getting applied along its axes. That's going to make it easier to control. If we had the forces were based upon where these engines were located and we put those engines off center, what would happen is, because they're not in line with that sort of pivot point, they would actually induce a rotation. So that's something we generally want to avoid, because that's then something we need to be able to manage and control against. So rotation isn't going to be something we focus on with this one. It's just going to be the thrust setup. But that's an important thing, that we want the thrust to be applied along our axes. That's going to avoid thrust-induced rotation there. Which that's something where, just from a general design point of view, that makes it a lot easier to fly. If we didn't have that, it would be much more complicated. So I've built this up. This was done fairly quickly with ProBuilder. I've also got a platform here and a little target platform that I'll be aiming to land on. And we're going to use the new input system for this, because that makes it much, much easier for setting up our control schemes. And I've also set up a Cinemachine camera that'll keep this in view for controlling it. So let's start to get this set up. So first thing that I want to get going is actually these visual effects. So I'm going to create here a new visual effects, and a visual effect graph, and this is going to be VFX rocket. And what I will do is each of these emitters, I'll select all of them, then I'm going to add visual effect and link them all to that same effect. Now, what we see here initially is what we would expect, that we have some emission starting already. Now we're going to set this up and get this configured so that we've got a nice sort of plume of stuff being emitted. So there's a few different sort of settings, things like that we're going to be needing. Some of the stuff we're going to also need to be doing is adjusting things like the spawn rate. Now, I want to make it that it's easy to control the rate of this, that I want to essentially have a thrust variable. So this is going to be something that the thrust variable, I want it to range from 0 to 1, And initially, I'm going to default that to, let's go for 0.5. We will change it back to 0 at a later point, but for now, 0.5. So I want to have that. And I want to have also this spawn rate here. I want to be able to control that from outside of this. So I'm going to have this a max spawn rate. I want to allow a fairly large amount, so I'm going to actually default that to 200. So at maximum thrust, I want it to then be generating 200 particles per second, so pretty decent rate. So we can do a lot of our basic mathematical operations. We can do multiplies, things like that. So I can feed that in here. Now, as soon as I change that rate, I need to also update the capacity here because I'm emitting a lot more. That means I need to support there being able to be a lot more active particles in the system. So I'm going to bring that up to 1,000. So that's good. Bring that up to 1,000. In terms of positioning the particles, those engines, I want the particles to be able to emit sort of in a circle. So what I'm going to chuck in here an initialize particle is if I do a set position, which I'll bring this up to here for the circle. And then if any of these ones we see an arrow, that means you can expand that out. So I can link in a transform and a radius. So I'm going to set up a float that'll be the emitter radius, which that can just be pretty small. The emitters are not that large. So I'm going to make that 0.1 and link that in. And then transform, well, I can actually just grab the transform and link that in. So now it's got the orientation of the object properly. So that's good. So, okay, so far so good. We've set the position. I'm going to get rid of the random velocity. The lifetime, because of the amount of particles we're emitting, I'm going to actually really reduce this lifetime. So I'm going to halve it. So the maximum lifetime goes to 1.5 seconds, minimum 0.5. So that's good so far. We'll deal with the output in a little bit because we've got a few things to do with update. Because these particles, we want them to be emitted with a level of force. So that's something where what we can do is in update, we can add force to this. And because of how I set it up, the force only needs to be on the z-axis. So I put a 1 here. You can see it's perfectly aligned for all of them, which is great. That's what we want. But I also want to be able to control what that force is. So I'm going to set up here. So I have a min force, which I'm going to set as 1. And I'm going to chuck in a max force. And I'm going to change that to 3. Because the idea being, I can bring in my min and max force and my thrust, and then I can do a loop. So I loop from min to max based upon that thrust level. And then that, I don't want to change all of the components there, I just want to change Z. So now we have something that based upon our thrust value, it's going to change how, not just how much is emitting, but the amount of force. So thrust so far is the only thing we'd be varying as it's running. And I can actually go in and check and see if I take the one that would be moving us in negative Y. If I lower the thrust down to really low, we can see fewer ones, it's moving slower till I get to stopped. And if I go all the way up, then it's emitting a huge amount of particles very, very rapidly. So that's good. So that looks great. I'm going to chuck in a little bit of turbulence. Now, not much, because we do want it to still be largely sort of oriented fairly in line. So we just want a little bit of turbulence. I generally prefer the look of the Perlin noise turbulence, so I'm going to go with that, but with a much lower intensity. So if we drop that to 0.5, it's still quite large. I'm going to chuck it to 0.2. And that's a little bit better. If we save that, make sure it's properly got it factored in. That looks all right. We've got a bit of variation, not too much. So that's good. Well, I don't want to output quads. What I want to output is, and we need it to be outside of that, create node, output, and I want to use a URP lit mesh because this is going to give me a much better effect. So I can bring things like the set size and set color over. Can get rid of this one because I don't need it anymore because we just want to output the meshes. Then mesh wise, I want to output spheres, color map. We already have a 1 pixel white texture. So now we've got these spheres being emitted. That's looking good. Blend mode, I find additive is going to make them sort of stand out a bit more. You get sort of much brighter looking colors like that, which looks really cool. So that's looking good so far. Scale of these, I like the variation over time that happens there. What I want to also do is have just a global scale of that so that I can adjust that. So scale 0.5, because then after we've set the size, we can do a multiply on the size. So you can use like a set operator working over a curve, and then you can bring in a multiply to do scaling of that. So that looks pretty good. Those are looking quite good. Now we can tweak this color curve. So we don't want it to be just sort of white all the time with that. I'm going to make these start at kind of a orangey color. Then let's chuck in another marker around 50, where that can start to sort of, I think, fade to a bit of a more yellow color. Then at, say, 75, we can go to, I think, a fairly dark gray. Should be good. Till then, finally, the white there. So then let's save that. So that's looking better. We've got the sort of brighter color there. And if we look in the actual scene, that looks pretty decent. I'm happy with that. So that's pretty much done for the effect wise. So I'm going to change the thrust back to 0. So, okay, that's good. We've got our thrust set up for it. Now we need to start linking that up to things, and we need to start getting this so that we have the inputs being gathered. So what I'm going to do is I'm going to create a script for the spaceship, and I'm also going to create one for those actual sort of rocket engines as well. So rocket engine. Reason being is that there is a couple of key little things that the rocket engines are going to be doing. They are largely a cosmetic thing, but I just want to have them easily controllable. So I'm going to give all of them the rocket engine script, which is good. So rocket engine is just going to be a very simple interface for being able to control the speed of those engines. So that's its only job. So it's going to need to talk to the visual effect. So it's going to have a using Unity engine .vfx. It's going to need then a visual effect, so the linked effect. Then what I'm going to do is I'm going to cache the thrust, but I'm going to set up a property that, well, the get side is really easy, just returns thrust. The set side is going to check if thrust is not equal to this value. If it is not equal to it, then it's going to update it, and it's going to go, hey, linked effect, set float, thrust to the new value. This is going to give us a handy way of being able to control and work with this. So then each rocket gets linked up to its emitter. So now we have a simple script that can control these particular ones. And then what the spaceship will do is the spaceship doesn't need to be aware of how that visual effect happens. The spaceship just needs to know, well, what rocket engines do I have? So the rocket side script is quite simple. The spaceship one is going to be using the input system. But the key things it's going to need is it's going to need, for one thing, all those rocket engines. So we're going to need engine, X, and an engine for positive X. So just naming them like this is going to make it that there's less potential for us mucking it up in the inspector, which would be something that could very, very, very easily happen. So we're just going to have that. So we'll get those linked up, and then we'll get the input system side of things set up. So the spaceship itself gets its script, and we link up -X. And because we've named these things appropriately, it means we can actually very easily look and check and see, okay, rocket, engine pos Z, plus Z, neg Z, neg Z, so we can easily check. So using the fact of the naming there to make it easier to know that we've got stuff set up correctly. So then once we've done that, we need to set up our player input. So we're going to use a player input on this. I'm just going to move it above spaceship. And I'm going to create a new set of actions. And this I'm going to call input config. So this is what that input config currently looks like. So I'm not going to change the player set of ones. I'm actually going to set up a new action map, because this is something where if you are having a character transition between different vehicles or something, you've got different control schemes, having different action maps is an easy way to manage that. So in this case, I don't want to replace the player. I'm actually going to start off with duplicating them. And I'm going to then rename this to Spaceship. We don't have fire currently. What we will have is, so move will be horizontal thrust. So all of those are fine. Those will map to a horizontal thrust. Looking, we're going to get rid of as well for the moment. And then what I will add in is I will add in vertical thrust. Space. So horizontal thrust is a value in a vector 2. Vertical thrust, we want that to be a value, and we want that to be an axis, because what that will allow us to do is, see how WASD is here as a digital normalized and a composite one? And if you look at the individual components, we can see how that works. Vertical thrust, we want to be able to do the same thing. So we can add a positive negative binding. So this will be set up for gamepad. So negative binding, so the one that will pull that down is going to be gamepad, and that will use left trigger, whereas positive will use gamepad and the right trigger. I could then add in another one for keyboard. Now we're using WASD, so positive binding, I'm going to actually go for space, and just trying to think of keys that you could feasibly be pressing together. And I think for negative, which will be rarely used, but I think left shift for negative. So that's good. We've got our min and max values. We've got similar sort of setup here. These ones we can just say, yep, gamepad. And these ones for keyboard and mouse. So that looks good. We save that. Once that's saved, see how it's got this default map here? We change that from player to spaceship. Now what we then do is we'll have our input coming in. So first thing we need to do is set up the logic for receiving the input. So the input system here tells you the name of the messages, because I'm using send message mode. So we can see the name of all of the possible ones that it could receive. So one of the ones will be protected void on horizontal thrust, input value. The other one will be protected void on vertical thrust, input value. Now I just want to combine all of these into the one vector3. So I'm going to kind of group these a little bit. I'm going to have vector3 input thrust. So horizontal thrust is actually giving us our X and our Z inputs. So firstly, we're going to grab the input. So vector2 input is value get. We retrieve the vector2. Then we can just say, well, input thrust.x is input.x. Input thrust.z is input.z. Whereas with this one, it will end up being input thrust.y is equal to value get float. Oops, that should be y. So it's good, we've retrieved the inputs. We're not applying any forces yet, and we actually won't apply any forces yet. What we're going to do is purely focus on changing the visuals. So what I'm also going to do is have a vector3 input thrust previous. And then down in update, f input thrust previous is not equal to input thrust. First thing we do is cation. So thrust input change. So if it's changed, then what I want to do is actually update the thrusters there. So we're just getting the visual going first. So first thing I want to check is if the value is not fairly close to 0. Because if it's close to 0, I want to just zero it out. So if mathf approximately input thrust x, so we have to do each axis. So to 0, so if it's not, so update x-axis thrusters. So what we would then do in this case is, so we've got our engine. So we'd be saying, well, engine neg x, its thrust there. So that gets a 0 to 1 value. We've got a -1 to 1 value, but that -1 to 1 value gets interpreted differently. So in that -1 to 0 period, that actually corresponds for just the negative thrust engine, whereas the positive x thrust engine would always be 0 at that point. So we need to do a little bit of remapping for this. So what I would actually check is if that x thrust, if it is less than 0, So if it's less than 0, then the negative engine does have an actual value coming through. Then what we can do is a mathf absolute input thrust.x, otherwise it's 0. Could also actually just do this as a minus, would work. But I think the mathf absolute is a little bit clearer in terms of what's happening. Otherwise, for the positive x1, well, if the thrust.x is greater than 0, don't need to do the absolute value. Otherwise, it's 0. And again, then with this, we just set both of these to 0. So this ends up, regardless, is 0. Because in this case, the thrust is so low, we don't want to be actually applying anything. So we use the same logic for y. Now again, copying and pasting code, it's one of those things where I'm never going to say you should never copy and paste code. It is something that it saves time, it makes sense to be doing it. You just want to be cautious and make sure you're not copying and pasting too large a chunk at a time. So let's do Z as well then. Because what we should find after this is that we can actually see the visuals working. Because the actual movement side is very little to this. Most of the work is in the areas outside of the movement. So it looks pretty good. Let's test this out. So if we go to test this at the moment, we'll see, we should see particles, but we're not seeing any particles even with input. And that is because, really easy to make a mistake. If we go over to the rocket engine, here, this should have been using a value. So because of that, it was actually failing to ever make changes to it. So we want to just be making sure we're properly checking the values there. So really easy to miss thing. Properties, you can introduce some really gnarly bugs. We can see, if I use the thrusters, we get our different inputs going. We do, however, even if I'm, because this is an older controller, so there is a little bit of sort of dead zoning with it. So we want to actually have a little bit of a sort of dead zone for it that we can control. So what I'm going to set up is a serialized field, animation, curve. And what this is going to do is this is going to be used to sort of filter and translate the inputs. So input translation curve, and what we'll do is with this input translation curve dot evaluate. Now that input could be negative, so we're going to do the absolute value, but then we still want the sign of it. So we can do mathf sign with a gn of the input.x. This will give us something that it's run the value, the absolute value through the curve, but then if it was negative, it's preserved as being negative. So we're going to use this for every input because that way we have that little bit of that controllable dead band there. So float input. Then I'll let us set up that dead band. What I'm also going to do is I'm going to get stuff set up for our forces. So I kind of want to control the horizontal and vertical forces differently because the vertical makes sense that that has a really high amount of force that it can apply, whereas the horizontal, we don't want it to be as large. So I'm going to have a max of vertical force. Remember, we weigh 1,000 kilos. So we want that to be fairly large. And then also want the max horizontal force. So that's going to be about 1/3 of it. Going to set up, so we'll have our linked rigid body. So that will be good. So I'm also, because I'm requiring that, I'm going to add in the require component. In a wake, I will populate that. So that's good. We've got our rigid body retrieved. We've got our update. We can apply force then to this. So because we're working with physics, we're going to do this in fixed update. Now, this is something where we don't need anything actually too complicated for this. First thing is we need to work out our thrust vector. Because if we just used our input there as the coordinates, that would move us in world space, and there might be cases where we want to do that. However, I want it to be relative to where the spaceship is currently angled. So I don't want to just use the vector in world space. So what I want to do is orient it based upon the spaceship's current axes. So that means I can do transform.right multiplied by input thrust.x multiplied by the max h force. Then I add to that transform, now in this case up, and this is by input thrust.y. But this one uses vertical force. And then finally, we have transform.forward multiplied by z by max h force. So just orient these so they're a little bit neater. So then to apply the force, it's really simple. Add force, thrust vector, and we specifically want this to take into account our weight. So we use force mode force. So let's test this out. What I should see when I run it is that I can move a little bit. And at first, nothing should be happening. It's going to take me getting the force most of the way applied. But we can see we're getting nothing, and that is because if we look, we forgot to set up our input translation curve. So I'm going to use just a fairly standard S-curve, and I kind of want to have at this first 5% of that curve is essentially just going to be flat, that the input, there's none of it. And then we can ramp up from there. That should give a bit of a dead zone there and a bit of a smooth one. We could also change that curve then quite substantially based upon however we want it to feel. So now we're getting rid of thrust, we can lift up, and if I hold it steady, we can kind of be balancing. And then I can move. Now because we're using force mode, some of that force then continues, but I can successfully move over and by slowly lowering the trigger can do not necessarily a particularly graceful landing. And you can also do like of that. It's fine, it'll buff out. And that stuff where, because it applies along the axes and the shape of this, I kind of did design it so it has a bit of a tendency to be fairly easy to position. But it means you can kind of hit a fairly good spot with the triggers for sort of bouncing around. And if you really want to go sort of full on with it, you can kind of try and fly inverted if you have much better coordination than I do. I definitely do not have the coordination for that. But this flies quite nicely. It's sort of quite zippy. And it can get pretty decent speed. If we get a bit of a turn on it, it can kind of go a little chaotic. And it's very easy, especially with my ability at steering, to go way off the mark. Now that was steering it with using the gamepad, which is definitely a lot easier. We can also use keyboard, but that is something that is definitely a lot sort of trickier because your keyboard inputs, they work, like they absolutely do. And we can sort of see we can get things a little bit more sort of balanced there, but it is definitely not that easy to be operating it. But with all of the thrusters, we've got pretty good control. And the Cinemachine camera means that it sort of pans around it quite nicely, which is great. So far, pretty good. Let's get a couple of other sort of improvements and additions to this as well. So we don't currently have any audio being emitted from this. Now I have grabbed a couple of sound files. These are from Freesound. I've put the credits in here, so I've extracted a looping portion or loopable portion out of these. This is something where if you're wanting to be grabbing these, you can grab the full sound effects there. These are Creative Commons 0, but please do make sure you include credits, things like if that there for these ones. These are really great sounds. So one of the sounds is quite a sort of loud one. I'm going to use that for the sort of main engine. So if we listen to that, it's quite a loud one. We also then have a higher pitched one that I think will be good for the individual sort of thrusters. So what I'm going to do is these emitters, I'm going to add a audio source to each of those. I'm going to turn off play on awake. And what I will do is, this is again, the rocket engines can kind of handle this themselves. So this will have an audio clip. And this will be engine sound. We also need them to have access to their audio source. So they kind of have to be attached. Well, the emitter is where we want the stuff. If we look, we don't have the audio source is currently on the actual emitter. So what I'll do is I want this to be here. Just means that the position is exactly at the emission point there. Linked source. Because what we will then also do, and so we're going to, it'd be fine to do this in start, linked source volume is 0. And we'll also update the thrust, make sure that is 0. So we just got everything properly initialized, which will be good. Because that linked source, I'm going to set the clip to be the engine sound. And then what I will do is linked source looped will be true. Now here, F thrust, because I could have it playing all the time and then stop it. It's probably fine to just have it playing all the time, I reckon. Linked source dot play. So we can just leave it playing. And then what I can also do is here, linked source dot volume thrust, but let's take a look at the units used for the volume. So volume is 0 to 1. So that's good. We might also want to have a max volume. So max volume, just in case we do need to lower that, which we might. But this just allows us to control that. We could even run that through a curve if we wanted. We won't at this stage, but that is something that you could absolutely do. So pretty much most of these ones, so the X and the Z ones, I want them to use, so not the emitters, the X and Z, I want them to use the rocket booster sound. Whereas the Y ones that are the louder engines, I want them to use the main one. Then we just need to link them up to their respective audio sources. So we can just link that up. So every single one linked to its audio source. And this will just mean then, as we are zooming around, we'll be able to have that audio feedback there, which will be really handy. And very easy for us to have added in that audio feedback. Like it's stuff that's quite simple and straightforward, which is great. It's kind of what we want. So we don't hear anything at the moment, which we shouldn't. But as we're using the main engine, the volume changes. And when I bring in the small engines, that changes as well. And everyone can enjoy my absolutely terrible driving skills. But conveniently, that shape just makes it very easy for it to balance. But we get our sound. So that was pretty straightforward. Well, seeing as we're using the new input system, the other thing we could do that would be quite straightforward for us to add in is some haptic feedback. Because we're already doing stuff where we're working with the thrust, things like of that. So what I could do is, and to actually do the haptics is pretty straightforward. So we would just update the ones. What I would do is float heavy engine. It's going to be mathf absolute input thrust.y, whereas the light engine is going to be a mathf absolute input thrust.x, and I want to kind of take I think actually adding both of those in might be the way to go about this. So a mathf absolute input thrust.z, but I think clamping that to 0 to 1. So it means if we're doing a lot of thrust there in X and Z, we'll be able to, that will actually have more of an effect. So going fully forward will feel the same as if we were going diagonal at a rapid rate, which I think will feel good. So then we can go, well, input, actually we can just go gamepad dot current set motor speeds, and we could actually set it. So these are 0 to 1 values. We probably want to chuck these through a curve. So I'm going to set up a couple of things for haptics. So this will be the rockets, engines. This will be the physics. Then we'll have one for the haptics. So first thing will be enable the haptics, because we might not want that enabled. Then we'll have an animation curve, low speed motor curve, and a high-speed motor curve. Could also have a max value. So point max low speed motor, and same for the high speed, which might make those just so it's not destroying our hands. That looks good. Those should be a range because they can only go from 0 to 1 anyway. Looks good. So what we would do down here then is, well, F, enable haptics, because otherwise we won't do any of this. Bring that in here. So set motor speeds, we give it the low frequency and the high frequency one, which I might actually rename those to low frequency and high frequency, just for clarity. Just means we keep everything consistent there. So, okay, heavy engine will use the low frequency motor. So we would do the low frequency motor curve, evaluate heavy engine, multiplied by max low frequency motor. Then we do the same thing with high frequency motor curve, evaluate the input from the light engine, we use that. So it's going to give us the input there. We also want to check and gamepad current is not equal to null. And I can't remember if there is a specific extra thing we can check to see if it is enabled. There it is. So we only want to do this if it's actually properly connected, enabled, things like that. Otherwise, there's no sense applying it. So let's test this out, and we should have then controller rumbles happening. Except we need to remember and set up our curves. Always forget to set up the animation curves. I'm just going to use a standard S curve. Generally find that works pretty well, but again, something we could easily tweak if we wanted to. So let's test this out. So applying a little bit of thrust, I'm getting a bit of rumbling. As I apply more, definitely can start to really feel the rumbling happening. And then same with the low frequency, so the high speed ones. It's a lot less. You can possibly hear that. So that's the boosters. And then this is the main thruster. So that's good. We have our rocket ship up and running. We have the ability to be maneuvering it around. We've got our visual effects going and synced to everything that's happening there with it. We've got audio and haptic feedback. It's working with keyboard and mouse as well, so we've got multiple control schemes going there. So we've got all of those bits and pieces up and running. So this is the current version of it. There's more that I'm going to be looking at adding to it in future. There's further bits I want to be adding there, doing some cool and interesting things with gravity. So there's going to be more to come with this. If you've got specific things you're keen on seeing with this, chuck in a comment below, and then those might be things I'll be able to work in the future. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, really helps out the channel, really appreciated. If you have any questions, chuck in a comment below. If you're looking for the code for the project, that is available up on GitHub. You'll find the link for that in the description. You can be using this code in any of your own projects, commercial, non-commercial ones. You're freely available to be using it in any of those. And if you're looking for other ways to support the channel, I do have a Patreon, and there's a link to that in the description below. But until next time, bye.